Okay, good. So I guess I'll start out with a question. I was here 2 years ago. Just kind of curious, did anybody attend my Collections Renaissance presentation 2 years ago? No? Okay. I guess that's good. This will be all brand new for you then. So what I'm going to start out doing is actually telling you a little bit about myself, because unlike Venkat, who doesn't need to be mentioned, he's been here so many times, done so many sessions, right? I've only been here once, and really, need to introduce myself. So as she said, I'm a VP at Goldman Sachs. I'm also one of the technology fellows in Goldman Sachs. There's around 45 technology fellows in our organization, which is around the, I think, 7,000, 8,000 member size. So another thing is I'm actually a member of the JSR 166 expert group. Does anybody know what JSR 166 is? Okay. So JSR 166 is one of the oldest surviving JSRs. It actually came about, I believe, in around 2004. Doug Lee is the spec lead. And what it is basically Doug Lee and the expert group and concurrency interest group have basically been adding things to the Java language over the years. So over the years, you've seen things like Java util concurrent come in. Recently in Java 7, you'll see the fork join framework. And basically, this expert group and this JSR keep continuing to add value to the Java language and the libraries. In Java 8, there's going to be some more additions, and that's actually something that we're working on in the expert group. So myself, I joined the expert group in June 2011. So it's kind of a privilege to be on there. It's basically Doug Lee as the spec lead. You've got Brian Getz, brilliant individual. Josh Block. Everybody know Josh Block? Okay, so these people don't need mention, but you have all these people that are either authors or in technology companies, and then there's me. So the question is, why am I there? What am I adding in terms of value? Well, as it turns out, I've been working in Java for quite some time, and in the spaces that I work in, and have worked in over the years at Goldman Sachs, we deal with things like very large Java heaps. We have had heap sizes on the order of, let's say, 100 gigs, and many of them. So we deal with like very large collection sizes. We also deal with many millions of collections. So think, a collection with 100 million elements, or that I have 100 million collections. So it's interesting in that space, what happens is memory becomes actually an interesting problem. As you have more and more collections, the overhead of that collection actually can present you some challenges. And you start to use more and more RAM just because of structural overhead. So quite a while ago, and actually I'll get this into a second. So other things, I guess, about myself, as the intro kind of said, I've worked in a number of obscure languages. I've listed here basically all the languages that I've worked in. You can't really make it out too well, but the ones that are in bold are the ones I actually got paid for. So has anybody heard of CA Realizer? Probably not. So CA Realizer was actually a basic that CA put out back in the 90s. It had a Windows 3.1 version and an OS2 version. Anybody remember OS2? Wow, I'm dating myself. So kind of gives you a view, I guess, like, some of the things that I've experienced. One of the most formative languages that I worked in is right here, Smalltalk. So for about 7 years, I worked for IBM Global Services and basically programmed in Smalltalk full-time. This had a profound impact on how I thought about software development. Smalltalk is a pure object-oriented development. And actually, let me ask a question. And I have a gift for anyone who says yes and can actually substantiate it with some proof. Is anybody else in the audience programmed in Smalltalk? No hands? Okay, well, keep trying. Keep asking questions. I'll give some stuff away. So anyways, Smalltalk, a pure object-oriented programming language, virtual machine-based, always had terrific IDEs. It was just a pleasure to work in. Once again, really shaped the way I think about software development. While I appreciate functional programming style, and actually I'll get into a bit that some of the things I'm going to talk about are going to be talking about functional programming style. Smalltalk and the way I think about things is really from a pure object-oriented style. I like to have object-oriented applications, and to me that means basically I want to have objects, and I want to call behaviors on those objects. So I want to have like object and message, and that's how I want my code to look. And that was nice and easy in Smalltalk, where basically you don't have things like statements. You can only accomplish things by calling object and message. So imagine you don't have an if statement, you don't have a for loop, you don't have a while loop. And the interesting question is like, well, how do you accomplish these things? And that you'll kind of see later like how you can accomplish these things in Java and how I kind of translated what I learned in Smalltalk into Java. So next point here. So I am actually the creator of a thing called GS Collections. How many people in the audience have heard of GS Collections? Well, that's probably because this is the first public announcement that we've made about GS Collections. So GS Collections is a collections framework that's been developed in Goldman Sachs over the last 7 years. It's a Java collections framework, and we open sourced it a few months ago. Now, one of the reasons we open sourced it was because I'm on the JSR 166 expert group. We have a plethora of experience using functional features in our collections library that are going to be able to automatically take advantage of Lambdas when they come out. So I'm going to get someone to raise their hand here. Who went to Venkat's session on Java 8 or to Simon's session on Java 8? Okay, good. So you learned about Lambdas a little bit. You're going to see Lambdas in this presentation. But what I'm not going to do is go into too much depth, because hopefully you got to see a little bit of preview from Venkat and Simon. So anyways, in terms of GS Collections being open sourced, it's available. You can go download it. It's in GitHub. Another thing that we actually open sourced as well is we open sourced our internal training. We give basically day-long classes to pretty much anybody in Goldman Sachs that wants to take it. You now have access to that training. It's in GitHub. The way the training works is it's what we call a programming kata. So there are basically exercises that you have to implement in the form of unit tests. The unit tests fail, and your job is to use GS Collections. Their job, if you choose to accept it, is to use GS Collections to actually get the test to pass. So that's out there as well. Okay, so preface. Collections are a fundamental part of any programming language. They're used in all but the most trivial of programming languages. How many people program in Java? Okay, we're getting lots of hands now. We're doing better. How many people use the Java Collections framework? Pretty much everybody. Anybody not use the Java Collections framework and program in Java? No, because you wouldn't be able to get much done if you didn't actually have collections. They're extremely useful. Now, the interesting thing is that the behaviors that you have available in Java on the framework are very limited. You basically have types like iterable, collection, list. And on iterable, which is the base interface for collections, you have one method on it. You have iterator. Now, iterable was introduced in Java 1.5. The intent being that it was kind of extracted out of collections so they could actually introduce the for each loop. So the for each loop just, as you probably know, generates out to an iterator. And to get things done, you call, for loop, and basically underneath the covers, it's calling iterator has next and iterator next. So at the end of the slides, which I doubt I'm going to get to, I have a lot of content here, and the intent, though, is not for me to teach you everything that you need to know about GS Collections. The intent here is that I'm here to tell you that it's out there and it's available. You have the training material out there. You can download it. You can use it. If you want, you can fork it. You can do whatever you want. It's in GitHub. It's open sourced. So we'll see how much we get through, and I would welcome all of you to, I'll be actually at the Goldman Sachs booth afterwards if anybody has any questions. So feel free to come talk to me. So anyways, if I get to it, what's interesting with Java is that it introduced and kind of replaced rich collection libraries of its predecessors with a minimalist approach. So once again, you have iterable with iterator. You can basically call toArray on a collection. And those are your options basically for iterating. Or if you use list, you can write a for loop with index access. So the interesting thing, as you've learned earlier from both Venkat and Simon, is that Java 8 will have Lambdas. And this is actually a key piece of functionality that will make functional APIs easier to use. In fact, my opinion, and that will go as far as disclaimer that the value of my opinion, is that this will actually help to make a functional API more preferred to use in a lot of cases. It's not going to get rid of for loops, but it's going to make it easier to use things like functional APIs. So you see a lot of new languages out there as well that are really recreating what I call the richness of old. And things that we had in Smalltalk 30 years ago are coming back in the form of Groovy, Ruby, Scala, Python. Well, I guess Haskell's been around a little bit longer. And the interesting thing as well is, in the presentation I gave years ago, I talked about what's actually been happening in the collection space in Java. There's actually been an emergence of various collection libraries that are reintroducing the functionality. So if you look, you've got Google Collections out there, which is starting to introduce functional APIs. You've got functional Java, which is basically a functional library implementing all the things that you'd expect to see with a functional style. There are also, probably upwards of around 10 to 20 other collection frameworks that are available in open source that have functional APIs. I'm not going to go into all of them today. Okay. So why GS collections? So I'm going to argue that it improves readability. I'm going to show you that it reduces duplication of iteration code. So if you went to Venkat's presentation, you actually got to see the indexed access for loop and how that got improved in Java 5 by using the new for each loop. And so it took away all the ugliness. But the interesting thing is, if you look in the JDK, there's an interface called random access. And random access, has anybody seen random access interface? So it's just a marker interface. And what it gets used for is basically, in the Java doc for random access, it says, if it's something like, if in the case that iterating over your collection would be faster if you used index access, you should implement the random access interface. And this will allow you in your code then to write if statements that say, if I have random access, I want to use index access instead of a for loop. So then you wind up once again introducing all this duplication of iteration code. So GS Collections also implements many iteration patterns on humane interfaces. So basically, we extend the JDK collection interfaces. So iterable, collection, list, set, map, which even though map is in the collections library, map is not a collection. It does not extend the collection interface. So we extend these interfaces and we add a rich API. We also provide optimized replacements for array list, hash set, and hash map. Okay, I'm going to try and give something away here, if you can answer this question. Who can tell me how hash set is implemented in the JDK?
It's a hash map and the values are kept in as keys.
It's a hash map and the values are kept as keys. So it is a hash map. Yes, and the values are implemented as keys. You are correct. So you got the answer to the question right. You get yourself a nice 4 gig USB drive with GS Collections installed on it. So that's interesting because like a hash set is a hash map with keys. What does that mean in terms of the memory footprint of hash set? And if you had a lot of them? Well, it means you're going to waste a lot of space on the on the hash set itself. And you think about it, what a hash map of keys that are the values means is that in the hash map, you've got a table of entry objects, and every entry object has a key and a value. The value is going to be null, but it doesn't actually get rid of the cost of having that extra reference. And if you're working on a 64-bit system, which most of the systems I've had to work on over the years, you actually waste 8 bytes per every reference, and then 16 bytes for the overhead of the entry object, and so on and so forth. What you'd really like to have is, just have the actual values in the hash set, and have a structure that knows how to do that. So I think this was a place where there was composition favored over inheritance, right? We will compose hash set out of hash map, but it's not what I would have recommended doing, especially because if you work in a large memory space, you're going to waste a lot of memory. So we have our own implementation that is not implemented like that. So we also perform behind-the-scene optimizations in utility classes. So we have to work with the JDK. It's actually one of the core philosophies of the design of GS Collections. It's not enough that, hey, I create this great collections library and it looks just like Smalltalk. Actually, what I've done is created a collections library that looks like a Java collections library. It just has Smalltalk behavioral methods and other, higher-level APIs. So in terms of dealing with other collections, we try and optimize as much as we can for you. Because with the framework developers, we like to provide optimization where we can, and we're not going to do it just guessing. We want it to be measurable. We also have parallel iteration. So because we work in this large memory space, think about it. If you've got 100 gig heap and you have 100 million trades in a collection, and you need to aggregate the market value of all these trades, well, if I've got a lot of cores hanging around, I can actually parallelize that activity. So what we had actually done very early on, almost like 6-7 years ago, we actually introduced parallel forms of all of our iteration behavior. So you'll find out methods later. What you'll see is that that same method probably has a parallel counterpart in some cases. So because there's algorithms that are actually not too hard to provide parallel versions of. Now the trouble with parallel, though, is we can hide the structural complexity from you, but we can't make parallelism any easier for you. You have to use parallelism and know when it's actually going to work for you and provide benefit. You could use parallelism and it actually could make your code slower, right? So like any optimization, caveat I would say is like only use it if you can measure that there's a benefit. Other things that we've actually added in the framework, so we've added types that are not included in the JDK. We've added a type called bag, which if you use Google Collections, you'll know as multiset. We have a type called interval, which is actually an integer interval. It's like, got a start range and an end range. We have multimaps. We also have immutable versions of all types. And I guess, the final point here is like, this is a mature library. It's been in development internally in Goldman Sachs for, 7 years. Recently open source. So the nice thing is you can take advantage of the investment that we've made. So I'd encourage you to go look at it, see what it's doing, see what it has capable. Okay. So I'm going to introduce some various patterns. And what I've done here, and I'll explain where possible, the interesting thing with patterns is that sometimes you'll see different names for the same pattern. So I use the Smalltalk pattern names. It's what I refer to as the Dr. Seuss API. You've got methods that rhyme. And I always claimed that the reason that these methods rhymed were we didn't have code assist back in the day. We had to remember things. So memory being what it is, 7 plus or minus 2 being a good number of things you can keep in your head. In Smalltalk, you had methods like select, reject, collect, detect, inject into, and then some the additive ones, any satisfy, all satisfy. But the first 5 really, rhyme, and it made it easier for you to actually remember them. So here I'm going to show you select and collect. I'm also going to show you a pattern called get if absent put. Okay, I think it's a good opportunity for a question. Ready? Who can tell me how put if absent works in concurrent map? So in concurrent map interface in the JDK, there's a method called put if absent. Right? Just curious if anybody's, okay. Yeah, so what's the value, though, that you get out of put if absent? Very good. Exactly. And when I get into get if absent put, I'm going to show how that's slightly different. So key to understand that. Put if absent is not get if absent put. Another difference is that, as you described, you have to put the value in that you want, right? In get if absent put, what I'll get into is like, you don't put in the value, you have a lambda there that will get lazy evaluated if the value is not there. Which means in the case of put if absent, if I put the value in, I may actually wind up have to create that value twice. So let's say I had a concurrent map of array lists, right, as the values. I'm going to actually have to create that array list, potentially twice, right? Because I have to create the array list when I call put if absent. So I'm going to talk about GroupBy, and I'm going to talk about the Java Collections tutorial. I'm not going to get into the tutorial. It would take me too long. I'll provide links to it. How many people have taken the Java Collections tutorial? It's a great tutorial. Helps you teach how to actually use JDK in the idiomatic Java form with collections. I'm going to take the tutorial. There's an exercise or a program called that calculates anagrams, and I'm going to show you some other patterns that fall out of this particular program. So I'm going to jump into it. How am I doing on time? Not too bad. Okay, so I'm going to talk about this pattern called select. Now select, another name, and you would have heard this from Venkat and possibly Simon earlier, is another name for this pattern in other languages and libraries is called filter. I think in Groovy it's actually called find all. So select in JS collections, basically what it does, and I'll show you using Java code. So what you do is you take a list of, let's say, integers here. And what I want to do is actually create a new list where every element in this new list meets some condition. Now this condition here, here I'm checking that each integer is greater than 50. And if that is true, I'm going to add to the collection. So this is how you'd write it in kind of idiomatic Java 5 form using the for each loop. Go to this side. So if I was to optimize this, oops, sorry, I mean to point it at you guys. What I would actually do is use the the random access approach, and I would actually use indexed access. Now this code gets a little bit uglier from here to here, right? And I also have those opportunities for bugs to be introduced, right? As Venkat said, you get the the less than greater than, or the equal greater than equals to less than equal to problem. There are potential for bugs. You get the off by one errors. Now in GS collections today, how many people know anonymous inner classes? Okay. Not too many, right? How many people are actually doing swing development? A few. How many people actually sort collections? All right, well, all of you are actually using anonymous inner classes. If you have to create a comparator, right, every once in a while? Yeah, so that's going to be an anonymous inner class. How many people do threading in Java? Okay, so you've had to create runnables, right? And you may have used anonymous inner classes for those. So here I'm going to show you with GS collections. Today, you can write this. In fact, you can use GS collections with JDK 1.5, JDK 1.6, JDK 1.7, and when JDK 1.8 comes out, you'll be able to use it with that as well, without me having to change it. Now what's interesting is the type that select takes, it's a type called predicate. And predicate is basically a single abstract method interface, so a SAM type, has a single method that returns a Boolean. Takes the parameter, and you've probably seen this like each before from one of the previous presentations. So here's the parameter that I want, and here's the condition that I want. Now what's interesting is, as Venkat kind of said before, I mean, Venkat, are you in the audience? He's here? This is a lot of stuff to have to write to effectively get this done, right? Kind of an overhead. Not very pleasurable to write. Now what's interesting is, even though Java has been kind of slow to get to Lambdas and to introduce them, and I've been waiting for them since, well, 2000, since I really started using Java full-time. What's interesting is the IDEs have actually made it easier to use anonymous inner classes. So IntelliJ will auto-generate this. If I just type new here, it's going to say, oh, well, you're taking a predicate. And actually co-generate everything except for the method body. So it's not so hard to write this, but it's kind of ugly to read, right? Now what IntelliJ actually does here, and people can tell me if Eclipse does this or not. What IntelliJ does is it actually has a feature called code folding. And what it'll do is, when it sees an anonymous inner class, it'll actually fold this up and really only show this and the method body, trying to hide some of the ugliness from you. It's still there, though. If you click on it, it's going to come back and excite you. All right, so other things that we have introduced into GS collections because of this pain. We have a predicates factory. Now what's interesting with the predicates factory is it's very easy to build up some standard predicates. Think of things that you would want to test that would return true or false. I'd want to test for equality. I might want to test greater than, less than, greater than or equal to, less than or equal to, between, in, out. Okay, there's no out. In, not in. And there could be null, not null, so on and so forth. There are a bunch of standard predicates that we've baked into this predicates factory, and you can use them. So they're all static methods. This effectively gives you back a predicate that you can then use. And you can actually stack them together. Now the trouble is, I wouldn't recommend doing this too much. It can, be even worse looking than just writing this at some stage. But where we ultimately want to get to, and something that we're going to be very easily able to take advantage of in Java 8 because we've kind of like embedded this in so many of the code bases we work with. We're going to be able to probably very easily, when Java 8 comes out, move from this to this. Now, the only thing that's changed here, right, is we got Lambda syntax in Java 8. So disclaimers being disclaimers, you know, it's supposed to come out in Java 8. I can't promise that this is the way it's going to look. This is the way it looks today. You can actually download a Java 8 binary snapshot, and you can actually execute, you know, code that looks like this. Your IDE is not going to like it at all. You're going to say, oh, there's a red and funny stuff, but you can actually compile it and you can actually run it. Now, what's interesting is here, this is a big change quantitatively. Qualitatively, it's the same, right? I'm still saying what I'm doing. I'm not saying how I'm doing it, right? This is much more declarative. It's like, this is what I want to do, and here's the condition I want you to execute. I don't have to worry about the actual iteration logic. Here, quantitatively, the change is impressive, right? Because all I need is the parameter list, and in Java 8, they're building in a nice feature. They're actually going to give you better type inference than we've normally gotten, specifically for Lambdas. So you see here I say each. What didn't I say? Yeah, I didn't have to say integer, right? So it just means that I have just less text to type, because with the type inference in Java 8, it's actually going to be say like, well, you've got a list of integer. I know what your type you're iterating over is, so I can figure it out for you. You could put it in if you wanted to, but it's not really helping the compiler. So yeah, so all that matters, parameters and code. Does that make sense? All right. This is another pattern. It's called collect. In languages like Haskell, you'll think of it as map, or Scala also calls it map. Somebody can correct me if I'm wrong. You know, the number of languages I can keep in my head at one time can be challenging. I believe JRuby, or Ruby itself, uses collect. I think Groovy uses collect as well. Anybody confirm or deny that? If you can confirm, I'll give you a 4 gig USB drive. Wow, nobody wants 4 gig USB drives. Okay. Anyways, so collect. What collect does is often called map in other functional languages. It's sometimes called transform as well. How many people know Apache Commons collections? How many people actually use Apache Commons collections? A little bit less. Apache Commons collections actually had a utility class called collection utils. It actually had methods like select. I think they called it select rejected. They actually have collect, but they have another method called transform. Now, collect and transform are synonymous sometimes. You'll sometimes see in other languages it called map or transform. But the idea here is it doesn't matter. You have to learn this name. If you're using Java collections, just like you're going to have to learn what map or transform mean in another language, right? But it actually is the same pattern. And the pattern is this. What I want to do is iterate over some collection. So in this case, a collection of people. Then what I want to do is, after having already created this target collection, what I want to do is take these people and I want to get their names. I want a collection of names. Does anybody have to write this pattern before? You've seen it before? Okay. Now, if you were to optimize this code, you'd actually write it like this. Now, it's interesting with collect. There's a cool behavior of collect, unlike select or filter, in that you know the source size, which means you also know the target size. You're going to have as many things in the target as you have in the source, as long as it's a list. If it was a set, obviously it would be a different case. But in this case, it's a list. So I can actually pre-size the collection. That's a good thing to do because it doesn't actually have to then grow and copy. Excuse me. And then I'm going to use the index access. So again, I've gone from something that was fairly readable to something that's a bit harder to read and reason about. In GS collections today, once again, between JDK 1.5 and 1.7, I can write this. So collect takes a different type. Select took predicate, returns a Boolean. Collect takes a function. Function takes one type as a parameter and returns another type as the result. So in this case, I take person as a parameter, and I return string as the result. So even more boilerplate that I have to write here with generics, right? And all I care about is this and this. Now, what's interesting in Java 8, there's actually two things I can take advantage of that they're planning, at least today, and disclaimer, once again, it may change, may not be the way it winds up, but You can use a lambda, so then it becomes people collect each get name. Or there's a feature called method references, which they're looking to add. And what I can do with a method reference is say, like, for this class, use this method. And it's the equivalent of writing this. Now, this is actually very succinct, right? List, collect, person, get name. Now, what I would argue is that this is more readable and both qualitatively and quantitatively better than the alternatives that you would write in idiomatic Java. Clear so far? It's going to get harder, I think. Ooh, more code. Okay, so back to get if absent put. So you've probably seen this pattern before. How many people have ever had to create a map of key to list or map of key to set? Yeah? So you've seen code like this before. What I'm doing here is I'm going to iterate over a list of people, and I'm going to have this map that I create of string to list person. And what I want to do is actually iterate over my collection of people and effectively group my people by the state that they live in. Now, in order to group them, I get a key from them, so I'm going to use state as my key. What I have to do is look in the map, and I say, get that state. Now, that state could be null, because I haven't initialized it yet, right? So I have to do this check. If it's null, create the array list. Put the array list in there, and then I'm going to add. This code right here is get if absent, well, actually not the add. This right here, get if absent put. So with the methods that we have available on our map interface in GS Collections, I can actually collapse this code down to just be, I iterate over the people, I get their states, and then I call get if absent put. Now there's something strange looking here. It's like, that doesn't look like Java. There's another feature coming in Java 8, and once again, disclaimers being disclaimers. It may or may not be there, and it may look different than it does today. But today, in the Java 8 binary snapshot that you can use, you can actually use this syntax, which basically what this is a constructor reference. And what this is saying is like, give me effectively I don't know all the implementation details here. We're going to translate to what I would have equivalently written with a lambda, where it's a 0 argument lambda. It has no parameters, and all I need to do is instantiate the list. But this doesn't instantiate. This just gives me a function that will get instantiated, assuming get fails, on the null check, and then it'll actually instantiate the list. It's nice and succinct, right? I could have written a lambda syntax, but I didn't because I wanted the text to be big. So can you guys all read the text? Yeah? Okay. If I wrote it with lambda, it would have been wider, and I would have maybe had to put add on a separate line. But you can see the add code there, right? So that's get if absent put. And once again, different than put if absent, because put if absent, I would have said new fast list here. I would have had to create it. Thank you. So this is just a promise to create the fast list. All right. So look at exactly the same code. And what I'll tell you is that I showed you one pattern called get if absent put, and there's actually another pattern here called GroupBy. GroupBy is a composite pattern. I actually can leverage get if absent put. Oh, and actually, let me just ask a question and get if absent put. Here's an opportunity, 4 gigs. Come on, GS Collections. Ready? What is something we can do by implementing get if absent put that you can't do by writing it by hand? Can anybody guess? There's an optimization I could take advantage of here. Okay, I'll tell you. I can actually, with get if absent put, make this an atomic implementation where effectively here I've had to do 2 hash lookups. I had to do a get and I had to do a put. I hashed twice. Technically I only need to hash once. And by having the method get if absent put, I can actually do that, right? Which makes then get if absent put, potentially more optimal than doing it by hand. So anyways, GroupBy. So if you look at all of this code, everything inside of, actually the whole thing is just GroupBy. This whole pattern is GroupBy. And what you're doing is, once again, you're taking some key for an object. That's what you want to group by. And then you've either got a list or set, in this case a list. And the values will be the list of the actual people. In GS Collections, I can write this. Now this is in the anonymous inner class form, right? So And you see a different type here. So we have a type called multimap. Multimap is the equivalent, so when I say multimap to string a person, it can be the equivalent. Although this could be a set multimap or a bag multimap or a list multimap. But in this case, it's going to be a list multimap because my source type is list. This is the equivalent of by hand having a type map of string to list person. And what you'll see is you don't need to define list. It's just assumed it's a multimap. Of course, it's got some collection container there. So we use the multimap type here. So GroupBy returns multimap. What do we group by? We group by this function. What do we want to convert from? We want to convert from the person to their state. And that's all the code I have to write. Now, what's interesting here is like even with the anonymous inner class syntax, this is quantitatively better than this, in addition to qualitatively better. I said what I was doing, and I don't have to write as much code, and I don't have the potential for as many bugs if I did this by hand. Java 8 comes out. I can actually use Lambdas, so GroupBy becomes as simple as this. All the cruft of anonymous inner classes goes away. I just have each get address, get state, calling GroupBy and people, and I'm done. Okay, so real quick, Java Collections tutorial. Go take a look at it. There's a section in there called algorithms. There's links in here, so this presentation, I believe, will be up for people to go through, so if that helps you find it, or Google works as well. There's this example program called anagrams 2 there. I'm not going to put it here. It'd be a lot of code. But what I'm going to do is describe what the algorithm does. What this algorithm does in the collections tutorial is it takes a list of words, right? Anybody tell me what an anagram is? Come on. Yeah, so exactly. So everything has the same letters, right? Okay, we can give one away. Let's say, map of list of strings, so and the key is string to list of string. And, well, we've seen a pattern before that kind of would handle that. It's really like a GroupBy pattern, right? Now, in the algorithm, in the tutorial as well, then the next thing you do is actually you want to filter the results of your anagrams. You only want to show anagrams that have a certain size. So let's say I want the list of anagrams that are greater than size 1. And then, so I want to actually get back this list. So you've seen a pattern for this called select, also known as filter. And then actually you're using sort, because what you want to do in the tutorial is take the list and sort it in reverse order, right? So we want the largest first. Then what you want to do is output all of the elements, so all of your anagram lists, and you want to show the size of the list and the elements in the list. So let's see what this can look like. Oh, actually, first we're going to start here. So when I implement this, in the tutorial, they actually just take a string, and they have a static function for converting the string to the sorted string. And what you have to do is say string to char array, then arrays.sort on that array, and then you have to create a new string. And what you wind up doing there is actually copying the string twice. Now, it's interesting as well, forget about the performance optimization, because who's going to use the anagrams? And apologies to anybody who has anagrams functionality they need to implement, sorry. But what you can do here is you can avoid the copying twice, and better than that, you can actually give a meaningful name to this. And I came up with the name alphagram. It's like, this is a special type. It's like a string, but all I care about is my very poorly implemented equals, because that won't work very well for anything but an alphagram. But once again, I didn't want to have to scroll down or left or right to have my equals properly implemented. And it actually works. But then I just need equals and hash coded implemented. So if I was to write this with GS collections, with Lambda support and all the things that are coming in Java 8, and I'm going to do it with get if absent put first, just so you can see what the difference is. And I'm using map first. So in GS collections, we have a type called mutable map. It's like map, only it has all the extra behaviors you like to be able to use. It's from alphagram to mutable list of strings. So right now I get more information. I see it's not just a string, it's actually an alphagram. And that has some meaning. So this is our map type. So I create the map, and then I create this procedure. So procedure is what actually gets passed to our for each method. And this is the first time you're seeing this. So for each, all it does, it returns void. It just does something for every element of a collection. So here I'm going to take this procedure, and you see in the procedure, right? I'm referencing map. Now, ooh, can anybody pick up the bug I've got in my slide? I'm sorry? No. What am I referencing here? Can I reference that there? I'm referencing this, right? I probably deleted it for the slide. Makes it look better. You need to have final in front of there. I can't reference a variable. So this is actually a lambda, right? It says, have a procedure which takes word and executes this code for every word. So it calls map get if absent put. I can't reference map within the lambda. So Java 8 is not getting closures. I cannot reference a free variable out here. I have to declare it final. So anyways, we do for each. And then what I want to do, so this actually has done my GroupBy, right? This is GroupBy implemented by hand with get if absent put. And it's not that great looking. You actually see I use constructor references again, because that was kind of nice. It helped me collapse things a bit. So this is just a lambda implemented as a constructor reference. But here what I'm going to do is I can take results, right? Sorry, I can set results. And results, what I'm going to do is take the map, and there's a method on map called select. Because map in GS collections, which there are slides in this presentation. There are design diagrams. You'll see how all the types are organized. I'm not going to have any time to get to them. But you can go look at them and see what the design of GS collections is. So mutable map actually extends an interface called rich iterable, which all of the types in GS collection ultimately do. So it has behaviors for select. Now in a map, select actually filters on values in the map. And that happens to be what I want to do here. I want to filter the list based on their size, right? Okay, I want to talk really quick. Then I want to sort it. Now this is interesting. This isn't like sort in collections, right? Because I'd have to pass a comparator. In GS collections, we have a method called toSortedListBy. And what it does is it takes a function. It says, I want to sort by negative list size, because I want it in reverse order. Can anybody really quickly tell me how you'd write this comparator by hand? It's okay, I don't have enough time for you to tell me. Now you have these other calls here, as lazy and collect. I'm going to skip over as lazy. If you want to come talk to me about what is as lazy, I can tell you at the booth. Or you can read about it in our extensive training. So if I was to write this fluently, I can actually write this as one line of code. I can just stack all that together, right? So the entire anagrams example I can put in this one line of code. Now, I'm not going to tell you that's a good thing to do. It may look cool. It may read fluently, but it's not very easy to understand because you don't get any information about each of these types. It would also be very difficult to debug. But the interesting thing to note here is that because the interfaces are rich and they keep basically allowing you to stack functionality, it's very easy to get understanding of behaviors available. I'm just going to show you GroupBy real quick because I'm out of time. But this is anagrams with GroupBy. And what you'll see is like now I have a multi-map. So instead of those 3 lines of code, I just say GroupBy. And I use that constructor reference thing again. I want to create a new alphagram. That's what I'm going to group by. And then I can do multi-map, multi-values view. You see select again to sorted list by. And then this. And yes, I can stack all that together. Not a good recommendation, but you can. And that's it. So I'm out of time. Do I have any time for questions? Well, being out of time would suggest I don't. I can? Any questions? I'll give you a USB drive if you ask me a question.
Any benchmark to compare like how it is performing? Compare the
great
actual
question.
JDK logic.
That was the unfortunately, benchmarking is really hard, and we're actually working on putting together a set of benchmarks for basic functionality that we can actually then publish. It just takes time and energy to do it. The trouble with micro benchmarking, which is what you'd have to do here, it's very hard to simulate what you're actually going to see in a production environment, and it's hard to get it to predict what hotspot is going to do, because hotspot's super smart, and it's hard to predict. Now, the interesting thing is our benchmarks that we use internally are typically large application benchmarks. So we see what's actually happening in a real live application. Now, I can't put those out into open source, so I have to write lots of micro benchmarks. We have some that we might put out sooner than later that actually compare our serial API to our parallel API. Once again, you're your mileage may vary on what hardware you run on, you know, different things, cache architecture, so on and so forth. So, everyone, thank you.
Like Google's also, they will give one. How better this?
How's it better? Okay, I'm going to answer your question with a question, and I'll give you a little detail. Google basically, and if anybody from Google here, you can slap me upside the head if I misquote here. I believe what they were looking to do is basically introduce new types like multiset and existing types. They weren't also looking to change the existing interfaces. So they're not looking to add the rich API to their types. They want the new types, and they want it genericized. So these types existed in Apache Commons collections. They don't exist they existed in Apache Commons collections, but they didn't have generics, right? Apache Commons kind of like, you know, died some unfortunate death of never being updated, right, to Java 5. So the question I'll ask you, though, is do you know what the cost of an empty array list is?
Cost of an empty array list?
Yeah. Anyone know?
10.
10. There's a backing array of size 10, right, by default?
So by default, 10 we can store.
So if I was on a 64-bit system, right, with 8-byte references, my empty array is going to cost, or sorry, empty array list is going to cost me how much?
640.
Sorry? Well, it's, okay, I'll guesstimate mental math. It's somewhere above 100 bytes, right? Okay. That's for empty, right? What should an empty list cost you? Well, not that much. So one of the things that we actually did in GS collections, and once again, our optimizations always focused on memory first. Sometimes you get performance out of that type of optimization, but it was always memory was the key. So what we did in our fast list class, when you create a fast list, we do not create a backing array of size 10. We do nothing. So it's not much at all. But then you get the benefit of empty is almost empty, right?
Question here. This side, left.
Thank you.
Left side.
And do we get a? Okay.
So we have Hashmap and Concurrent Hashmap.
Yes.
So Hashmap. So we are using Concurrent Hashmap. It looks like the memory footprint is a fatty.
Yeah, actually, if you follow Doug Lee's concurrency interest site, which I'd recommend go look at it, he's implementing what he's calling Concurrent Hashmap version 8, right? Because he's trying to, yeah, Concurrent Hashmap has like these arrays, like these segments, yes, right? And it winds up taking a lot of memory. Now, that doesn't hurt you so much if you've only got one of them, but if you've got millions of them, it's horrible.
No, we have millions. That's why I'm asking. Because
yeah, I would tell you don't use millions of Concurrent Hashmap. So it's when I do memory tuning with apps, that's the first thing I tell me. Oh, if you got a million concurrent hash maps, you can save a lot of memory by getting rid of those.
So then what do you recommend? Like, so then we come up with our own implementation like synchronized hash maps, or because hash maps are less fatty than...
I would not tell you to do that. It's hard enough to implement a hash map. It's really hard to implement a concurrent one. And you know, let smart people like Doug Lee do it. So actually the work he's doing right now on Concurrent Hashmap version 8 in Java 8 is going to make the cost of a concurrent hash map around the same cost as a regular hash map.
So you recommend not to use concurrent hash map for millions of entries?
Or if I check in the concurrent hash map that we've had to implement for exactly the same reason, you could take a look at that one.
You are a GC.
Yeah, I haven't.
GS, sorry.
Yeah, I haven't put that out yet.
So is that the case for even like linked to blocking queue, all those things? Because it all comes under the concurrency package. Because we face the problem even in the, all the
I would say it's going to vary depending on the types that you're using and what you're doing. You're going to have different challenges. Creating lots of anything, if it's not a efficient data structure, is going to be bad. But efficiency, concurrency, there are all these challenges that we have to face, right?
Yeah. Just assume this, right? Okay, if you wanted to put just a long object in the queue, it just creates a linked list node object, which is of more bytes than long. And
so you're using long?
Just a long object.
Like as in big long? Like next to primitive long?
It's just a primitive long.
So you're wasting more memory creating the big long, sticking it in the list than you are in the queue than you are in the queue itself probably. So that's an interesting problem as well, like with primitive collections.
Okay. Yeah.
So
Thank you.
I think we're way over, right? Or do we have one more time?
We have time for two more questions.
Okay.
One here and we'll
We
take
hand-
one here.
That was a good question.
Have any improved versions of these classes in GS collections
Of arrays?
for arrays and collections? We have a class, utility classes in collection
So
framework.
we have an array adapter which provides like the whole protocol. We also, and once again, getting back to that memory idea, we have immutable collections, and there's a really cool feature of immutable collections. And if, I'm going to take too long to answer that. And with immutable collections, when you create them, in the very small sizes, let's say I have an immutable list of size 1. I call that like an immutable singleton list. You don't need to have an array for it, right? I just need to hold on to the reference. And you think about that, what you can actually do is, and we do it up to size 10. Actually, I like to say mine goes to 11, but we have empty. We have singleton, doubleton, tripleton, quadrupleton, quintupleton, sextupleton, septupleton, octupleton, nonupleton, and decapleton. But you don't see any of those names. You just know that you have an immutable list. And when you create it, either when you grow, it's going to stay optimized in the small range. But if you convert, let's say, a mutable collection to an immutable, it's effectively going to trim. If it's really small, they'll use that. Even when it's really big, we put in an optimization to say, well, for an immutable array list, I can keep the array, and it's going to be the same size as the elements, so I don't need to actually keep a size variable. Right? So like just anything that we could do to save memory, we do that. So
Where can we download your GS?
when can you download it? As soon as you leave here, you can
Where can we
click the
download it
download. What was that?
Is it the GS framework? Is it a part of your company, or you donated to any open source
So
organization?
we open sourced it in GitHub ourselves with an Apache 2.0 license. So similar to, we didn't go through a foundation. We just did it ourselves, right? So anybody use GitHub? GitHub's cool, right? Yeah, so you can take a look at our GitHub site. You can download it from there. Just real quick, and I'm kind of interested, right? This is the first time we're publicly talking about. Well, actually, I'm sorry. We talked in 2010 about Caramel, but really publicly talking about actually the open sourcing of this framework, right? So you all are the first people to hear it, right? First time I'm talking about it. Interesting thing though is I'm kind of curious if people are interested in it. Right now, we're not going to accept contributions. We'll accept ideas. I'm curious if people are interested enough in it. If they'd like to contribute, let me know, right? Say like, hey, I want to contribute this, right? Because it's something that putting it out there took a lot of work, right? No reason for me to have even extra work if there's not going to be any interest in it. So if you're interested and you'd like to be able to contribute, let me know that, right? And I'd love to see that happen. So.
Well, we have one last question here.
Yeah, hi.
Yes.
Yeah.
Yeah, I got it. I was just taking care of logistics.
Thanks for making the JS collections public, and what a good day to do that.
The page views later. See, I want to see like 1,000 hits.
Specifics of the heap, where you said that you guys need 100 gigs of heap and so on and so forth. One part of the question says that so no matter how much of the memory footprint you would have reduced because of using some of the optimized data structures and algorithms behind it.
Yep.
How about the pauses? How about GC? How do you really handle that? Because that's something because it's kind of scary when we go beyond 8 GBs of heap, right? And then you guys are talking of 100 GBs.
Having had 64-bit heaps since Java 1.4, it hurts. It really hurts.
Exactly.
It's just we have some problems that really lend themselves to leveraging large heaps, and GC is always a concern. We're always like watching to see like someone's going to solve the GC problem magically for us, right? So yeah, you get very good at GC tuning, and once again, like you worry then about things like new gen and old gen and temp gen, perm gen, all the gens, Jenny gen. So
okay, but how much of the memory footprint have you reduced because of any specific data points?
It varies. If you use lots of sets, I can save you let's say 4 times the cost of hash set than our set. Okay. But not many people use lots of sets. Array list, I'll save you 8 bytes.
Okay.
With our fast list, just because and this may seem horrible, I don't have mod count in fast list. So you won't get a concurrent modification exception in fast list. Ooh, right? It's not a concurrent list, right? Why do I need to have a mod count variable for it, right? So save 8 bytes. So if you got a million, lists, I'll save you 8 megs.
Okay.
But that's very small, right? It's really in the set and map range that you're going to save more. So you can save a lot with immutable collections, though. If you, let's say in the large heap case, if you're loading up a lot of memory and it's staying static, I could actually leverage immutable collections for that. And they're going to be trimmed. They're not going to have backing arrays in the small range. And that was actually something I worked on in like 2004. We had that case. I had millions of objects that had lists for parents, lists for children, but the lists were always like in the 2 to 3 element range. So I'm saving that like 10 size default array by having these optimized data structures. And then when I load them up, they just sit there, don't grow and do anything. So it's like you're loading up and then you kind of freeze your state. So that actually, you get a lot of potential memory savings if you can do that. And if you have that. But not everybody has that problem.
True.
So it's going to vary.
Any specific data set, any data structure which exactly deals with kind of the big data stuff, probably an in-memory computation or so on?
Well, I guess there are things out there like there's a lot of interest in I think different large memory spaces, right? And there's a lot of caching products out there. You've got things like Gemfire and Terracotta and their operating space. GS Collections is all about the actual collections that you're writing in Java.
Any new data structure with GS Collections introduced would be handing a good set of probably an increase in the existing ones.
Okay, all I'm going to say is I'm not giving you 5 USB drives. No, I'm sorry. Do I need to